Okay, I'm going to do a daily repair video on this pair because there are some interesting aspects to this pair. These are SS4s, they're obviously the wide plate versions. They are the Type 2 version because they've got these elongated sort of little dots and slots, as I call it. They're more slots than dots on this particular model. If these were just straight lines, that would be a Type 1 and older SS4. Now, because this is a pair of customers, a pair of customers' irons for repair, we will always go through a quick inspection on the video. This pair are pretty well worn, a lot of dirt. I also see a crack. I can't see where it is now. Yeah, there is a crack in the, if I can get that to focus, just a little crack in there. You can probably see it. That's actually on the arm, so they shouldn't get worse, but it's worth noting these things down, because if the customer spots that when they come back after repair, and customers are certainly more critical when they come back than they have been in years, so we always note things like that crack. Hinge caps are present, but they are completely worn, shiny. The cable feels very stiff. I've got to say, I think this cable has been replaced. My gut instinct here is that it's a Type 2 cable and a Type 2 socket, which was always a hideous design, and we'll be changing that, but we'll have a look at that in a minute. So we've got a few scratches on the ceramic plates and a bit of dirt here and there, so we record all of that on the film. So next stage, as always, trying to gently pop off the hinge caps. That one's come off just fine, and that one is also good. We're going to get the hinge pin out now. We're going to unscrew it. We've got a bit wedged in the work surface. Make things easier. So screw out, pin out, pop these open, and actually we do not have a Type 2 cable and socket. We've got a Type 3, which is the newer version, but I suspect whoever fitted this has not bothered to put any grease on the contact areas, and that's why that's so stiff. If you look, I mean, that really is stiff. Oh, yeah, no, there's absolutely no grease on there whatsoever, so it's a pretty big mistake. Whoever did that might have been the customer. So we will put a little bit of contact grease. We use two types. We either use Electrolube CG60, which is what I've got here, and we also use another contact grease from a British company whose name escapes me. It really depends on what's available from suppliers, because supply has been pretty bad. So now we should have a much better movement there. Still pretty tight, actually. I wonder why that is. I think we'll just apply a little bit more on there, right the way around. Not normally this tight. You know what? I don't like the look of that socket. I'm going to change the socket for the customer, because this cable should be very easy to spin round. The problem is, with the tighter the cable is, it will then twist rather than spin, and the customer's new cable is not going to last very long in that state. So I'm not sure where the problem is. It's either the socket or the cable. One of them is not quite right. That hasn't been fed through there either, and whoever's done that, you probably can't see that, but they have crushed the blue wire in between the arm cover, so that has been very poorly fitted. I'm going to grab a genuine socket from my bag, and that seems to spin better than that one. Still not perfect, it's not as good as I would like. Let's just grab one of my cables and without grease. Yeah, that's better. I think this cable is oversized. Let's see if we can do anything with that. So I've just run the Dremel around there, and we'll see if that's made any difference. If not, I think we'll be changing the whole. Nah, that's really not made any difference. So we will be changing that whole cable. Right. Let's just see if our cable spins freely in there. Sometimes they're a bit oversized. No, that's perfect. So we will start again, but with a new cable, one that actually fits. A little bit of grease. So you can see how a straightforward problem can turn into a bit of an issue. Okay, so we are going to leave the, see how much easier that spins now. This is not going to get twisted. So I will keep my new, used but genuine socket back in its bag, and as I say, the routing of this has been done incorrectly, so I'm going to route the wire correctly. The brown wire should go underneath this capacitor. In this case it's been slid down the side, which is not good. The blue wire that's been pinched has only been pinched. It's not caused any serious damage, but obviously you don't want cables pinched, so we'll make sure that doesn't happen when these go back together. Just trying to spin that eyelet round, it's not having it. Let's try again. That's better. And after this remedial work, we'll actually have a little look and see what the fault is. Right, so hopefully you can see there the routing of the brown is underneath the capacitor and the blue goes down the side. So okay, so on to what the actual fault is. So we are on a low ohms reading, the scale rather. We're going to check the thermal fuse, which is fine. We're going to go over to the elements, which are also fine. Switch feels absolutely fine. I'm going to put the cover on, making sure that we do not catch any of the wires. There we go. We do not clean customers' irons for a number of reasons. Health and safety for me mostly, because I don't know what on earth the customers put on these over the years. It's the customer's responsibility to clean their irons, so for my protection I do not clean them. And also, if we did try to clean them, it's going to, the length of time to do that is going to be quite substantial, and also we don't know what products the customer might be allergic to, so if I leave any cleaning residue on these, there could be consequences there. So they come in filthy, they go back filthy, but working and safe, and it's down to the customer to clean their irons. Okay, so I have no idea what the fault is, we have no description. We're going to check R8 and R11 in case either one has failed. So no, both of them are absolutely fine, but they are the originals, so we will be changing both of them, because I know at some point they will fail. very easy to change for me. Obviously I've got the Ursa tweezers, but if you've just got a soldering iron, then you just apply some fresh solder to each end of the resistor and alternate backwards and forwards, heating each end up until you can just wipe the resistor off. To replace, you just put a little bit of fresh solder on one pad, hold the resistor with tweezers and melt it into place, and then go off to the other end and apply the solder. The resistors are very close to the arm on these SS4s, so you've got to be very careful not to burn the plastic alongside here. Now, something you can't do is check the PIC processor yourselves, because you're not going to have the tester, but I'm going to test it just to see if there's any issues with the thermistor that would be causing these to play up. The reading was 111, which is about right for the temperature in the workshop today. You wouldn't have seen it, but the red light came on, so I'm not seeing any other fault. So we'll plug them in and we'll see if they are working correctly. That cable socket might have been intermittent. It's hard to know for sure. Let's see if they fire up now. I'm just going to plug them in. Everything appears okay. So they are on and heating up both sides. We're going to let them heat up fully and just check the temperature. 110. On this wide plate you're going to be getting a 10-degree increase every couple of seconds, really. That's the sort of speed to expect them to heat up at. Aha! I don't know whether you can hear it. Okay, so this is, I'm glad I filmed these because this is going to be an interesting repair now. So there is an issue as they are heating up. They got very close to the correct temperature and then started with this bleeping noise. So there is something wrong with them. Obviously the customer wouldn't have just sent them in for no reason, but it's not one of the obvious common faults. Now I need to get another meter. So any capacitance meter will do here, and just on this board there is a capacitor. It's on the other side. I'm just going to show you the contacts. There's a contact there for it and this side. But what I want to do is, with it in circuit, I just want to get a reading. Set to capacitance, and we're just going to stretch these probes over and get a reading off of that. Helps if I can see the display. And the reading I'm getting is 27.15 nanofarads. Now that is totally incorrect. The reading should be around 220. The capacitor is one of these, and if I try and get the reading for you, can't see that. Well, 192. That's a little low actually. I'm going to put that to one side for further testing. Let's grab another one. I really want to be seeing the reading up in the 200 range. Let's try this one. Yeah, that is what I'm expecting from one of these capacitors, and that is what needs changing. I'm just going to double check this one, and if that reads low again, it's going in the bin because it's already started to fail. Actually, it's pissing me off, so it's in the bin. Okay, now unfortunately we are now working with a very hot pair of irons, so we are going to have to unscrew the circuit board and lift that out. get rid of the arm. Yeah, still stinking hot. Okay, so the way to approach this really is to bend the capacitor up, and without burning yourself, just try and melt one contact as you're pulling on the capacitor from the other side. Unfortunately a bit hard to show on camera, it's hard enough to do anyway. Once we've melted it and pulled it out a little bit, you can perhaps go in from the other side, just heat the leg up and pull, and now you can see we've got one side completely out. We're going to try and get into the other side, heat that up. There we go, so that one is out, and that is going in the bin with that other one that read a little bit low in value. Now, getting these back in, you can try and clear the holes of solder if you have some desoldering wick, but if you haven't, it's probably easiest to try and melt the solder as you feed the legs back in. So that is what I'm going to try and do with this pair. Trying to do these as most people at home would be doing it. I'm just going to apply a little bit of fresh solder onto there so we can melt it quite easily. Right, so we are going to melt this side first and push the leg in a little bit. That's gone in. Sorry you can't see that very well, but I'm sure you understand what I'm doing. Okay, so what I've done there is melted the solder and just fed the legs through. Now if you go back to the side it's really soldered on, you will probably see that the solder has come through and it's just a little bit too much there. So I'm just going to wick a little bit off, make sure we've got good contact at that side as well, and we are done. This is not a common problem, but it can be very frustrating if you don't know what is causing that. This resistor is available, this capacitor is available on our website to purchase. I don't remember the price off the top of my head. I remember most customers will post the irons into me at this point rather than go through that performance trying to change the capacitor, especially if they haven't got the required equipment. So we're obviously making sure all of the silicon gets put back in, everything else looks good, the wires are all correctly in place so we're not pinching anything when we put this cover on. And I'll just tighten these screws up and we'll test again, and this time we will get up to the correct operating temperature without all of that bleeping going on. You can buy very inexpensive kits for measuring capacitance, resistance, diode tests on eBay. This I've had for donkey's years. I can't even remember where I got it from or how much it was, but I like it because it's got the probes at the end. I actually use it for testing continuity of thermal fuses and things as we post them out to customers. I like to absolutely double check that the brand new component is going out fully functional, but then I do switch it to capacitance mode for this. But as I say, there are loads of cheap options, little kits that you can build on eBay, Amazon, wherever you like to purchase things from. You know, I'm talking 10-15 quid for a kit that you can build yourself for testing basic testing of resistance, capacitance, diode function, you know, that sort of thing. It's very handy in this situation. Okay, so we are just reassembling the hinge pin. I'm going to leave the caps off till we've tested. So we are back on. I'm not expecting any issues this time. K-type probe goes in, gently press down. And there we go. These wider plate ones will take a few seconds just to stabilize, and we are up to 186. So actually that's absolutely bang on. So that is done. We have no more silly bleeping noises coming from these, and that is a successful repair. We will switch over the plug to the pat tester, and we're just going to make sure the switch is on and carry out a class 2 pat test at 500 volts, and that's test 83, and it's a pass, so we are done. So yeah, today's repair video was a slightly more interesting one than the others, because that is quite an unusual fault. I probably only see that once every few months, but yeah, there you go. SS4s Type 2.